Hello everyone, welcome to Augment Tech. In this session, we will be learning about Python data types. By the end of this session, you should be able to understand Python data types, built-in data types, getting the data type, setting the specific data type conversion, and Booleans. I'm excited to get started and I hope this went from you. Let's get started with data types. In programming, data types is an important concept. Variables can store data of different types and different types can do different things. Python supports wide range of data types like integers, booleans, floating point numbers, complex numbers, and built-in data types known as sequences or collections. Data types represents the type of data stored into variable memory, and the data types that are already available in Python are known as built-in data types, and the data types which are created by the programmers are known as user-defined data types. Now let's see what are built-in data types. Python has following data types built in by default in these categories. Let's have a look. So here we have the data types in category. The text type belongs to string. Numeric types are integer, floating point numbers, and complex. Then we have sequence types like list, tuples, range. Mapping type like dictionary. Set types is set and frozen set. Boolean type is bool. Binary types is bytes, byte array, memory weave, and none type is none type. Now let's see getting the data type. So you can get the data type of any object by using the type function. So here type function returns the data type of a variable. So here we say x equals 10 and print type of x would return the data type of a variable. Because 10 is an integer number here, it should return the output as class int. Now let's see setting the data type. So in Python, data type is set when we assign a value to a variable. Let's say x equals hello world. Here hello world is a string because it's enclosed in quotations. And x equals 20. Here 20 is an integer value and we are assigning value 20 to our variable x. So this is how we set the data type in Python. Now let's see how to set the specific data type. Setting the specific data type. So if you want to specify the data type, you can use the following constructor functions. Let's say x equals string of hello world, x equals int of 20, x equals float of 20.5. Now let's see type conversion or typecasting. So type conversion is converting one data type into another. So you can convert one type to another using int, float, and complex methods. So there we go. Here you can convert an integer to float, a float to integer, and integer to complex. And then we can go and check the type of the variables. Now let's see what are booleans. So booleans represent one of the two values or results in one of the two values like true or false. In programming, you often need to know if an expression is either true or false. You can evaluate an expression in Python and get any of the two answers like true or false. When you compare two values, the expression is evaluated and Python returns the Boolean answer. So basically, if you have to compare two numbers, let's say if you want to check one number is greater than the other number or one number is lesser than the other number and so on, you get the output as Boolean. So here, let's say we check for 10 greater than 9, 10 equals 9, and 10 less than 9. So all of these three print statements will give us the value either true or false depending on the comparison results. Now let's hop to PyCharm and check out the example of data types. I'll see you there. Now here I'm on the PyCharm, so I'm going to right click on my project name, go to new, and create a new Python file, and let's name this as data types. CC datatypes.py has been created. So now let's say Python supports wide range of data types. Out of this, the first one we will see is none type. So here, let's say I have a variable a in which I do not have any value to store, and I'll try to print this variable a. Alright, so now what I'll do is I'll simply go and run this datatypes.py file. So I'll go to this datatypes.py, right click and run data types file. So you see it gives me an error, syntax error saying invalid syntax. Obviously because we have created a variable but we aren't assigning a value to it, right? So when you do not have any type of value to assign, let's say integer, floating point, number, string or complex, any of these values, instead of keeping a variable empty, you can just assign a none value. That starts with capital N because it is built in. And now I can also go and check for the type of A. And now let's run. There we go. You see, it prints none and also the class here is none type. Alright. Now let's see what are numeric types. So in numeric types, we will be looking at integers, float, and complex. So let's say a equals 10. Print a and check for the type of a. So type function is going to return the data type of a variable. So now when I go and run, you see the output is 10 and class in because 10 is an integer number. So integers here are whole numbers. What if I go and say f equals something like 10.0, print f and check for the type of f. Now if I go and run, it gives me output as 10.0 and then class float. Alright. Another important thing is that variables can also store negative values. So here I can go and say negative 10, here also negative 10.0. So this doesn't make any difference to the type of the variable. So you see, it still says class int and class float. Now what if I say C equals complex numbers? So complex numbers are made up of two parts. One is the real part and the other is the imaginary part. For example, if I say 2 plus 3j. Alright. So here 2 is the real part and 3j is the imaginary part and j here is the standard coefficient. So if I go and say print C and also check for the type of C and run. There we go. You see it gives output as 2 plus 3j and class complex. So here 2 is real part. I'm going to write a comment saying 2 is real part. 3j is imaginary part where j is standard coefficient. Now when I say j is standard coefficient, let's see if we can use any other letter here or character here other than j. So if I try writing I and run, you see this gives me an error, syntax error saying invalid decimal literal. So it means the imaginary part of complex numbers will always have j as the standard coefficient. Now let's see what is getting the data type. So we have already seen how to get the data type of a variable. For example, if I say a equals 100, print a. So using type function, I can get the data type of a variable. So now when I go and run, you see it gives me class int and 100 is the value that we have stored in a variable a. Now what exactly is setting the data type? Setting the data type is nothing but, for example, if I say a equals 200, so assigning a value to a variable is nothing but setting the data type. Again, I can go and print the, again if I want, I can go and check the data type of a. So this data type could be anything. It could be integers. If I say 0.0, it could be float. It could be complex. It could be string. It could be Boolean as well. So now we will go and see what is Boolean. So Boolean is a data type that results in true or false. So here what I will do is I'll simply write print, and let's say we will try comparing two numbers using the comparison operators. If I say 2 is greater than 3 and if I run, you see I get the output as false. And when I say 2 less than 3, I get the output as true this time. So now I can also go and check the type of this expression. So here I can say print type of 2 less than 3. And now when I go and run, you see it says class bool. Or I can just store this expression in a variable. Let's say e equals 2 is not equal to 2, this way, and then I can say print type of e. Alright, so now when I go and run, you see this says class bool. If I go and print e, that should give me the value either true or false. So 2 not equal to 2 is false. Alright. Now I can directly assign the built-in values true or false to my variables. For example, if I say g is a variable true, and then let me print g, also check for the type of it. Print type of g. So now when I go and run, see this actually gives me an error. The reason why it is giving me an error is it says name true is not defined. It's a name error, right? So if I try putting this in quotation, this becomes a string, right? So that will give you the output as str. If you see, I do not want this. I actually want this to be class bool. So whenever you have to write the values true or false, or whenever you have to assign the values true or false, the T of true should be capital and the F of false should be capital. So we are supposed to use the built-in values here. So now when I go and run, you see the output is class bool. Similarly, I can say for false as well. If I say h equals false, I can say print h and print type of h. So now when I go and run, you see the output is false and class bool. So this is about the Boolean data type in Python. Now let's see string data type. So I'm going to use a simple example. Let's say s equals, the string is Python. I can go and print the string s and variable s and also check the type of it. So here Python is a string because it is enclosed in quotation. You can use either single or double quotations. That should not make any difference. So now when I run, you see the output is Python and class str. Let me change the quotations from single to double. And now when I go and run, there we go. You see the output is Python and class str. Alright. Now what if I go and say something like s equals 10, print s and also check for the type of s. So now if I go and run, let's see what happens. It says 10 and class str. The reason why it is not giving the class to be integer or type as integer is because when you write a number inside the quotation, that is no longer a number, that becomes a string. So when you write a number inside the quotations, that becomes your numerical string. And when you have characters inside your quotation, that is actually a character string. Now let's see what is bytes and byte array. For example, here if I say x equals d and then quotations hello, I can print b and also check the data type of it. So if I say, sorry, this should be x, not b. B stands for bytes here. So now when I say type of X and run, there we go. You see it's class bytes. Let's go and check for the byte array. Now let's see if I say X equals byte array of 5, and let's print the value of X as well as check the type of X. So now when I go and run, there we go. You see this is the output for byte array of 5, and you see class, it says is byte array. Now let's also check the memory weave. So I'm gonna say X equals memory weave of bytes of 5. And now let's print the value of X and also check the data type of it. Now let's go and check the output. So you see it says class memory weave, and it also shows memory and a specific address. So it's returning the memory weave of the bytes 5. Now let's go and see how we can represent our integer number in different formats. So here I'll say represent numbers in different formats. Now for representing number into different formats, we have built-in functions available. Let's say for example, let me list out the functions or the conversions or the representation. So here I want to represent my integer number in binary, hexadecimal and octal representations. So how we can do this? I can say print. So bin here is the built-in that converts or represents your integer number into binary. So let's say bin of 10, and then print hex is for hexadecimal, hex of 10, and then print oct of 10. So now when I go and run, there we go. You see the output is 0B1010 for bin of 10, that is binary of 10. So 0B here stands for binary. 1010 is the representation of 10. Then for hex, we have 0x that stands for hex, and A is the hexadecimal representation of 10. And then 0O stands for octal. 12 is the octal representation of number 10. So here, hexadecimals are base 16 numbers, octals are base 8 numbers. So now when I go and change this value to 12 and 12, let's see what output it gives. So for 10, it is A, and for 10, it was 12. It means for 12, it should be C, and for oct of 12, it should be 14. Let's run and check. There we go. You see, the output is 0xc and 0O14. Now what if for hexadecimal I give a value as 7 and run? You see it says 7. And what if I give value as 14? So now when I run, you see it is E. And if I say 9, it still says 9. Okay, so from 0 to 9 the numbers are same, or from 1 to 9 the numbers are same. As soon as I write 10, that becomes A. Alright, for octal, if I say oct of 7, so it's 7. As soon as I change this to 8, see this is 10. Okay, 8 is 10, and 9 will be 11, and your 10 will become 12. Alright, so this is how you can represent your integer numbers in different formats. Now let's go and see what is type conversion or typecasting. So it is converting one data type into another. So for example, let's say I have to convert a floating point number into integer number. So first we need to have a floating point number stored in a variable. right? So first we need to have the source, and then we can convert into the target data type. So for example, here if I say a equals 12.5, let me go and print and check the data type. It's print of a. Okay, so let's quickly run and check if this gives float. Yes, it is float. Now I have to convert this into integer. So how do I do? Again, after conversion, I need to store this in a variable. Let's say that variable is b. B equals int of a. So here is integer. When I convert 12.5 into integer, that is a of integer, it becomes 12. So now when I say print b and check the type of b and run, there we go. You see the output is class int. So this is how we successfully converted a floating point number into integer number. Let's try doing the reverse. If I have to convert an integer to float value. So first we need to have an integer. So there we go. Here I say x equals, let's say the floating point, an integer value is 10. And if I say print x, print type of x. Though you can skip these two lines when you have your source, you already know that your source is in some data type. So you can go and skip these two lines and directly convert it into the target value or target data type, and then you can check just to verify if it's converted or no. So now what I have to do is I have to take another variable. Let's say float of x, print y, and then print type of y. So now when I go and run, you see the output is 10.0. 10 has been converted into floating point number, that is 10.0, and the class here is float. Now let's try converting a string to float. Okay, so what I'll do is I'll say s equals, let's say my string is Python. I want to convert this into float. So first I'll go and print this string and also check the type of it. Print type of s. And then let's say s1 equals float of s, print s1, and also check the type of s1. So here I'm trying to convert the string Python into floating point value. Let's go and check what output it gives. So now when I run, this actually gives me an error saying value error, could not convert string to float. So whenever you have to convert a string to float, we need to make sure that the string is a numerical string and not a character string. So that is why, because Python is a character string, it will not convert. What if I go and say something like 100, and now when I go and run, there we go. Let's check the output. So you see 100 is string which is converted into float, 100.0, and you see the class is float. Similarly, you can convert a string to integer as well. And now let's go and see how to convert an into an integer to complex. Let's see if this conversion is possible. So here what I'll do is I'll first have an integer number. Let's say a equals 1, print a, and then print type of a. Okay, and then b equals, I want to convert an integer to complex, so here I'll write complex of a, and then say print b and check for the type of b. And now let's run and check what output it gives. There we go. You see we can convert an integer to complex number. So because here we have only real part, so it automatically adds 0j as the imaginary part. All right. Now let's see how we can convert a complex to integer. Alright, so let's go and see if it is possible to convert complex to integer. So here I say x equals, let's say the complex number is 2 plus 3j. You can even write 3j plus 2. That should again be represented as 2 plus 3j only. I can go and say print x and also check the type of it. And then y equals, here let me say complex, sorry, I have to convert this into integer. So here I say int of x, print y, and also check the data type of it. So here I say print type of y. Okay, so now when I go and run, so what's actually happening is, you see, it gives me the output of this 2 plus 3j and type is complex, but it is not converting into it. So it actually gives an error saying type error, int argument must be a string, a byte-like object or real number, not complex. It means that the conversion of complex to integer is not possible. So I'm quickly gonna comment this. This conversion is not possible. Conversion of complex into integer or floats is not possible. Now let's see what are mutable and immutable objects. So mutable objects here are everything in Python is made up of objects, and these objects may be mutable or immutable. Let's go and see what mutable objects are. So these objects, mutable objects, are built-in types that can be changed. Examples are this. So we haven't seen this sequence types yet. We'll see them at later sections. So lists are mutable, sets are mutable, and dictionary is mutable. So once defined, you can change the sequence types at any point. That is why they are mutable objects. Now what about immutable objects? These are built-in types that cannot be changed or cannot be modified once defined. So these are the basic data types like int, float, bool, and strings, sequence types, and tuples. So here I can say built-in data types that can be changed or modified are mutable objects. The built-in data types that cannot be changed or modified are immutable objects. Now this was about the basic data types in Python. Let's hop to the quiz. Let's start the quiz. Let's have a look at the question number 1. Dash is used to get the type of data. Let's have a look at the options. Options are, option A is type A is type, option B is type function, option C is ID function, and option D is all the above. Pause the video and try answering this question. Now let's have a look at the answer to this. Answer is option B, type function. So type function is used to get the type of data, or type function returns the type of the data, whether it is integer, whether it is float, whether it is boolean, and so on. Now let's see question number 2. Booleans represent dash values. Let's have a look at the options. Option A is true, option B is false, option C is both A and B, and option D is none. Pause the video and try answering this question. Now let's have a look at the answer to this. Answer is option C, both A and B. So Boolean represents both true and false values. Now let's move to the next question. Question number 3. Converting one data type into another is known as dash. Let's have a look at the options. Option A is type, option B is type conversion, option C is type function, and option D is all the above. Pause the video and try answering this question. Now let's have a look at the answer to this. Answer is option B, type conversion. So type conversion is converting one data type into another. Like from integer to floating point values, floating point to integer, integer to string, string to integer, and so on. The only conversion that cannot take place is complex to any other data type. So that was all about data types in Python. So we have seen the different basic data types like integers, floating point values, strings, complex numbers, how to represent numbers in different formats like binary, hexadecimal, octal. We have seen Booleans and how to set the data type, how to get the data type, and converting one data type into another, also known as type conversion. So that's all for this session. Hope you enjoyed the session. We'll see you in the next.